Hello, welcome to our class. My name is Doug Hoffman. I'm the Executive Director of NORMI, which is the National Organization of Remediators and Mold Inspectors. We're a training organization and certifying agency for mold professionals throughout the United States. We actually started in July of 2004, started doing training on the first licensing law for mold professionals, and that was for mold remediators in the state of Louisiana. That was in 2004. Since then, several other states and municipalities have come on board, and we are the training provider for Texas, Florida, Louisiana, District of Columbia, and New York. They're the only 5 that actually regulate the mold profession. We were invited by ISSA to become a strategic partner with them in the training of indoor air quality issues because from the beginning, we trained on mold as an indoor air quality problem. If you think about it, it was kind of interesting because mold at each of its 4 stages is one of the 4 major components, what we call the toxic soup, of indoor air quality problems. At spore stage, it's floating around in the air, so it's a particulate. It is, of course, an organism. It grows, so it's a biopollutant. It's also, when it begins to grow, puts off VOCs and gases, in some cases mycotoxins, and it smells. When it's growing, it smells musty. So mold really does become, in a lot of ways, a surrogate for many of the other indoor air quality issues. We talk about this all the time in this way, that if you remove the mold from an indoor environment, successfully remove it, you're actually cleaning up the environment in a lot of different ways. And I guess the example that I use that most people really connect with is if you have a mold spore floating around in the air and you're using a AFD or air filtration device as an air scrubber to filter the air, it's not going to take the mold spores and leave everything else in the air. It's going to take everything, the pollen, the dead skin cells, everything above 0.3 microns. It's going to take it out of the air. If you're wiping down a surface that has some mold on it, you're using a good biocide, which is obviously anything that would kill biological contaminant. It's not going to kill the mold and leave the bacteria. The point is that it's going to keep that surface clean and really kill all the microorganisms. And so in a very real way, mold does become a surrogate for many other indoor air quality issues. So today what I want to talk about is I want to talk about best practices for sanitizing air and surfaces, because the protocols that we utilize not only in the mold industry, but also in effective cleaning, can be holistic by way of cleaning both the air and the surfaces. And so that's what I want to talk about today, best practices for dealing with and sanitizing the air and surfaces. I want to start by talking about a couple of quotes that I've found interesting in regards to indoor air quality. OSHA says that poor indoor air quality can be a common problem in workplaces because employees spend a large portion of their day at work, and indoor environmental quality of work facilities can have a noticeable and sometimes chronic effect on employee health. And we're going to talk about that, this connection between indoor air quality problems and people's health. And specifically as facilities maintenance directors or employers, we need to be very aware of what our employees are talking about in regards to their health, because those health issues that they're facing may be as a result of the environment that they're working in. I often say in our classes, if you get a headache when you go to work, it might not be the boss. It might be some environmental issue. And so we as employers need to be conscious and aware of what those health issues might be. It goes on to say typical undesirable air quality conditions include poor ventilation, mold exposure, temperature and humidity extremes, and potential exposure to workplace chemicals. These conditions may lead to frequent headaches, lethargy, cough, and have the potential to cause more serious conditions like asthma and pneumonia. And those are really 2 different things. One is sick building syndrome, the other is building-related illness. And we'll define each of those in just a few moments. So you'll see what the differences are in those kinds of issues that might result from our poor indoor air quality in our environments. The EPA says, and this is talking about houses, but it also applies to office and commercial environments, some health effects can be useful indicators of an indoor air quality problem, especially if they appear after a person moves to a new residence, remodels or refurnishes a home, or treats a home with pesticides. Think about this from a commercial standpoint. We just moved one of our companies into some new offices and larger offices. Painting issues that we didn't have before, painting odors, carpet smells, a lot of things that are going on in this new facility that was not in the other facility. And we've got to figure out how to deal with that and clean it in a way that we're dealing, again, holistically with both the air and the surfaces. It goes on to say, if you think that you have symptoms that may be related to your home environment, discuss them with your doctor or your local health department to see if they could be caused by indoor air pollution. You may also want to consult a board-certified allergist or an occupational medicine specialist for answers to your questions. I'll give you a little bit of hint about this. I was actually in a class several years ago in Los Angeles from the Cancer Control Society, and I learned about a whole host of doctors in the Association of Environmental Medicine, AAEM, and those doctors specialize in dealing with environmental issues and how they affect people's allergies. And so there's definitely a connection, and you're going to see as we talk today that they're getting better and better at determining how to tie people's health issues to environments. It's an evolving science, but they're moving closer and closer every day to being able to make those kinds of connections. Real-Time Lab, which is a lab located in Houston, and they've been working on this for a really long time. It says if you or a loved one is suffering chronic or from a chronic condition, mycotoxins from mold may be the blame. We understand the psychological and physical stress that toxic mold-related illnesses can bring. That's why getting the answers you need is so important. And Real-Time Labs is the only lab in the U.S. accredited by regulatory organizations like CAP and CLIA to perform tests on you and your loved ones. Here's an interesting thing that's happened. I've talked about tying environmental issues to people's health. One of the things that's fascinating to me is the ability of labs like this lab to be able to do DNA testing and actually connect a specific strain of a bacteria to someone's blood or their health issue, or of a fungus. And so now through DNA testing, they can test the patient and they can test the environment, and they can say this contaminant that the patient is suffering from actually came from this specific environment. And you can imagine how that's going to impact legal concerns and how it should impact us as employers when we talk about protecting the health and the safety of our employees. And so that's one of the reasons why this subject is so important, and best practices for, again, from a holistic standpoint, the air and the surfaces. I want to define some terms, sanitizing, disinfecting, and sterilizing, because I think those terms are used a little bit too loosely. And I want to make sure that as we're talking about sanitizing the air and surfaces, that we are in fact utilizing those terms correctly. So sterilizing is making something completely free from microbial contamination. And I just want to tell you that's a very, very difficult thing to do. And in most situations, they're not very successful at it. Even in hospitals, keeping surfaces and the air sterile is virtually impossible. And so this is typically done in healthcare settings where contagion and infection are serious concerns. You can imagine what might have to go on in any environment to actually make it sterile. So we're not talking about sterilizing anything. Disinfecting is to destroy or irreversibly inactivate or kill infectious fungi, bacteria, and viruses, but not necessarily their spores, as claimed by the label of a particular product. The EPA regulates disinfectants, as you probably know, and on the SDS sheet, you can find those active ingredients. and what the EPA has actually registered, they're the ones who are monitor kills claims, and kills claims are related to the disinfecting that is done when you utilize those chemistries correctly. We do a class that I'm going to mention here shortly called the Certified Sanitizing Professional. And one of the things that we spend a lot of time talking about is the fact that we're really sanitizing, not disinfecting. Disinfecting has to do with specific chemicals that you use, how those chemicals are used, specific dwell times, a lot of detail that is not really discussed much in the sanitization world, which is really what we're talking about today. So what is sanitizing? Well, sanitizing is really based on testing, and it's based on pre and post testing. You take a pre-sample, you implement a sanitization protocol, and you take a post-sample. If you've in fact reduced the microbial load on that surface or in the air, then you've sanitized it. You've not sterilized it. You may not necessarily have disinfected it, but you've sanitized it. So sanitization is the reduction, not necessarily the elimination, of microorganisms from an inanimate object, usually substantiated by objective lab testing. And the reason that's important is because you want to substantiate the fact that you've sanitized an environment, but you don't want to overpromise and underdeliver. You've not sterilized it. We're going to talk about the difference between a clean environment and a cleaner environment. That's a huge difference. Clean sounds pretty absolute. We try to talk in terms of comparatives: cleaner, healthier, safer, those kinds of terms. And those you can substantiate that you've sanitized properly with pre and post testing. So what we're going to accomplish today is we're going to talk a little bit about the NORMI professional practices, which is our best practices. This was written in 2015. It's now become the document for training in all the states that require mold licensing. And the reason they do that is because they require the trade associations to write best practices and to do the training on those practices. And that's what this document is all about, talking about mold assessing and also mold remediation. So we're going to mention that and talk about that for a little bit. But this book is really important. If you don't have a copy of this, I think you really should get it. It's a great book on indoor air quality, written specifically for facilities maintenance directors and employers by Burroughs and Hansen, called Managing Indoor Air Quality. And they set up a five-phase process that really helps understand what you can do as a facilities maintenance director. And that's really the first three phases, phases 1 through 3, before you turn it over to a professional. So there's some things you can do in-house before you have to outsource this to a professional if you're trying to find out if there is even an indoor air quality issue. And then finally, I want to talk about our new training program, the Certified Sanitizing Professional. Some of you will be interested in that to supplement some of the training that you've been doing with the ISSA on cleaning protocols. So what's the key to success? I want to tell you, when you're talking about sanitizing environments, even though we're talking about a holistic approach, which is dealing with air and surfaces, there is no silver bullet. It's about cleaning and doing good air purification and air filtration, scheduled maintenance. There's a lot of things involved. It's about being trained properly and using the correct protocols, and that really is the key to success. One of the things that I talk a lot about is redundancy. You do a lot of things and you do them right, and then if you miss something or you don't do something well, those other things will pick up the slack, and at least you'll get the results that you want. And again, that's a cleaner, healthier, and safer environment. Where are these indoor air quality problems coming from? Now, this, of course, is a house, but same thing happens in our offices, because most of our offices have kitchens, they have bathrooms. We don't typically sleep there, but we do spend a lot of time there. And so a lot of the things that we see in a house, we also see in a commercial building. VOCs, for instance, from perfumes and hairsprays and cosmetics. A lot of dental offices now that you go to, at least that I've been to, will have a sign and ask that their patients not wear perfumes or cosmetics when they come to have their teeth fixed. Well, why? Well, part of it is because people are allergic to a lot of those things, and they want to have a cleaner environment by lowering the VOCs. Good builders that we work with will try to utilize low VOC paint, so there's not as many off gases in that environment, from carpeting and from painting and draperies and furniture and so forth. One thing you might not know is that the paints that we utilize are awfully toxic in terms of off-gassing. And when you walk into a new painted environment, you certainly can tell that because you can smell those styrenes and other chemicals that are there. What we don't think about sometimes is that even when that odor goes away, some of those paints, according to scientists, can off-gas for up to 10 years at low levels that we don't smell it, but no doubt that it's still having its effect on that environment. And then, of course, there's it suggests animals, the dander, dead skin cells that we're producing as humans, dust mites, pathogens that are on surfaces. We're concerned about contact transmission. We should also be concerned about those things being transported on the air, which we'll be talking about here shortly as well. So there are a lot of different problems in our indoor environment. And there's another slide. This next picture shows you kind of how they're generally categorized. But I want to give you, from our standpoint, from an indoor air quality standpoint, when we talk about all the things that could be out there, dust mites, food, chemicals, mold, mildew, tobacco smells. Did you know that a single cigarette produces over 4,000 chemical gases, 43 of which are carcinogenic? So that's a huge problem in terms of creating a toxic environment, especially for people who have allergies or concerned about allergies. So how do we categorize these indoor air quality contaminants? We talk about 7 components of indoor air quality, and it's odors, gases, biopollutants, particulates, temperature, humidity, and air movement or comfort. Those 7 categories, you can take virtually any indoor air quality problem that you see, and you can put it in one of those 7 components. Why is that so important? The reason that's important is because if you're only addressing one of them, you're only taking 1/7 of the solution. And so I can give you this example. If only you're dealing with particles because you've got a good filter, then you're only dealing with 1/7 of the problems that are out there. Proactive air purification technologies will take care of neutralizing VOCs, of gases, of odors. It'll kill bacteria on surfaces and in the air, and it will also remove the particulates. So now you're dealing with 4/7 of the problem. Correcting the relative humidity, making sure that the temperature is correct, that you've got plenty of airflow and air movement. Now you're dealing with all 7. And this is the idea of taking a holistic approach. As I always say about indoor air quality, it's a multifaceted problem, so it needs a multi-strategic solution. And that's the way we want to deal with indoor air quality issues. Let's talk about air movement for a minute, because this is really kind of an interesting thing that folks don't think a lot about. But in commercial environments, and this is a rooftop air conditioning system, and you can see that this has a fresh air makeup coming in here from the left. As the air comes in, it's mixed with the contaminated air that's coming in from here. Hopefully it's filtered or purified, and then it's sent back into the environment. So you've got fresh air coming in from the outside. What are you bringing in with that fresh air? Are you bringing odors? Are you bringing particulates? Are you bringing contaminants? Well, of course you are. And so if you're not treating that before it comes into the environment, now it's going to be brought into the environment. It's going to be circulated throughout the environment. And of course, then it's going to be recirculated back through the air conditioning system. So the idea of an air conditioning system is to primarily dehumidify, but it's also designed, hopefully, to purify the air so that anything that's in that environment, when it's recirculated back through the air conditioning system, is going to provide cleaner and healthier and safer air in the environment. So that has to do with air movement. This is a really great little illustration of what's called in our business the stack effect. And as you know, by convection, Air is always moving up. Heated air, hotter air is rising. And so with that air, there are things traveling with it. So think about that for just a second. This is an example of smoke being moved up through the air conditioning system. But what's being moved through the air conditioning system? Well, one thing that's definitely being moved, if you think about how air is traveling, and I use this illustration because it makes a lot of sense to folks. If you burn popcorn in the kitchen, you smell it in the bedroom, right? And so that's because of the air conditioning system is moving the air in the environment. And actually air is moving in the environment. I'm moving my hand. It's moving air in the environment. So as we walk through, and as the air conditioning system is on, ceiling fans, whatever's happening, convection, air is moving. And as that air is moving, what's moving with it? Heat. Heat is moving with it. And what's moving with it? Pollutants. On that airflow, you've got particulates floating around like small dead skin cells, submicron particles that are floating around. You've got other types of pollutants that are passing through that air, odors and gases, and then also moisture. Moisture is moving as well. And so you've got all of these things going on. If you think about an air conditioning system as being primarily a dehumidifier, which is what it really is designed to do, then the most moist air in the environment is going into the air conditioning system. The least moist air or the dry air is coming out of the air conditioning system, the supply. So where are most of the dead skin cells and mold spores all trapped? They're trapped in the filter, where you also have the most moist air going. Sounds like a great formula for some pretty big mold issues. And that's exactly what happens in a lot of cases, is now that filter actually becomes a media for mold growth, and it becomes the problem. This talks about airflow anomalies, what we call typically dead zones. And let's suppose that in this particular environment, in the bathroom, the men's bathroom, they were getting the smell of acetone. How could that possibly be happening? Well, here's what's interesting about this. If you think about this, all of these rooms are either under positive pressure. You see the air is going out of the doors. They're either under positive pressure or they're under negative pressure. And in the case of the men's bathroom, it's under negative pressure. So anything that's in the hallway is being sucked into the men's room, but not being sucked into the ladies' room. So the odor that's coming from the chemistry lab, which happens to be acetone, is now showing up in the bathroom. So that's where that odor is coming from. And oh, guess what? It's also showing up in classroom 2 and classroom 3. How do you determine this? You determine this by an assessment, by evaluating the HVAC system or air conditioning system, and evaluating airflow. Very easy test to do. The point is that if you understand how the air conditioning system works, now you can determine where some problems are coming from. Interesting observation. I did a cruise ship recently, and it wasn't a large cruise ship, relatively small, but it had 9 air conditioning systems, plus 360 individual air conditioning systems for each cabin. So all the common areas were covered by these 9 air conditioning systems. So I asked them for the as-built of the mechanical drawings, which I got, and I was able to identify which areas were covered by which air conditioning systems. So of course, if you've got air conditioning system number 1 and it's actually distributing air to the elevator shaft on the port side, then any contaminants that might be in the top would also be at the bottom, which was exactly what was happening. Well, when I got done and explained to them these 9 systems and what they were actually covering in that cruise ship, the facilities manager went, now I get it. Now I know what the problems are in each of these rooms. So this is just a simple thinking through kind of common sense approach, but airflow can tell you a lot about what's going on in an environment. And that's what we do in the assessment side. Obviously, some things are pretty obvious. So you look up at this and you go, yeah, I think the air conditioning system definitely needs to be addressed. Look at this. This might not be quite so obvious, This could be dead mold. It could be live mold. Obviously, a moisture meter test would let us know that, or thermal imaging, infrared, would let us know if that was a moisture problem. It could be an insulation problem. Maybe the box that holds this supply register has no insulation around it if this happens to be an attic. So you might look up and see this, but that doesn't necessarily tell you exactly what the problem is. It could be the air conditioning system, or it could be something else. And of course, that's what a professional assessment is to determine what the issues are and where the issues are coming from. So I utilize this phrase all the time in my training. I think it fits with the medical industry, obviously, and it obviously fits with our industry. And that's this, that prognosis without diagnosis is malpractice. You can't offer a solution until you know what the problem is. And sometimes the only way to find a problem is to do a full-blown indoor air quality assessment. I wrote this article some time ago for CMM, and it's called Look Up. And the point is, it says your facility's infection control issues may be coming from your vents. So we spend a lot of time cleaning surfaces, and we typically have a scheduled maintenance program where we're cleaning the surface. Did you ever wonder where that stuff's coming from? It's coming from the air. In the most part, it's those things that have been floating around in that environment for a while, and now they've settled out in the air. Now they've settled out on a surface. I use this illustration. It's not really pretty, but I use this illustration a lot. If you look at a shaft of light, you see a lot of specks in there. A lot of those specks are dead skin cells. And so that becomes our dust. About 80% of them, according to scientists, is dead skin. Well, if you go to a movie theater and you look up, what you're looking at through that shaft of light is the dead skin of everyone that's been in that room over the last few days. Not a very pleasant thought, but the point is that's where our dust comes from. How many hospitals have you been in? How many healthcare facilities have you been in? How many restaurants have you been in that you looked up and looked at the supply register and thought, maybe they need to clean their duct system? A lot of the problems, this HVAC system is not always the problem, but it is almost always a problem when it comes to contaminations that's in our air and also finding itself now on our surfaces. This is not quite so obvious, but in an assessment that I did one time, I was able to look at the A coil. This is the inside of the air conditioning system. It's actually looking straight up into the A coil. The A coil is where the coils are cooled and all the air goes through that and it cools the air. Well, because of the filter that was not very effective, this is the garbage that actually was on the inside of the air conditioning system. Think that could cause a problem with indoor air quality? Yes. Think that could cause a problem with inefficiency of the air conditioning system? Yes. And so this is the kind of thing that maybe not so obvious, but can have a huge effect on air quality. And I think sometimes what's interesting to me is air conditioning guys don't always know exactly what the issues are. This one was not quite so obvious, but I'm going to show you what happened. You can see this is a rooftop unit. This is the fresh air makeup where the air comes from. And over here, out of the picture a little bit, was this little puppy. You know what that is? That's a vent, a VTR, coming up from the bathroom. And so this was over here off to the right. Because this is under negative pressure, guess what they were smelling in the indoor environment? That's right, sewer gas, wondering where it was coming from. Well, and they looked everywhere. They looked at floor traps, they looked at toilets, they looked at everywhere. Guess where it was coming from? It was coming from that little stack on their roof. So sometimes it's not quite so obvious, but if you got a good building science background, which I do, I came from the construction industry. I'm a licensed general contractor, licensed master plumber, licensed master roofer. So I've been in the construction industry. These are the kinds of things that we look for. And so it's obvious to me, but it might not be obvious to a lot of other people. So we did an environment, a big commercial building that was filled with offices. and they were having some concerns, and so we went in to do the assessment, and this is the room where the air conditioning system was. It handled the entire first floor of this building. And these are supply registers, so the air conditioning system is here. These are supplies, actually supply trunk lines going out to each of the rooms. And this room was, this unit was sitting inside of a room, and the room was under negative pressure. So the air was coming through the door, going into this system, and then it was being cooled and sent back out into the offices. Guess what we found in this room? Now remember, this room is under negative pressure. All the air in the building goes to this room, and then it's redistributed to all the other rooms. And this is what we found. Piping, water piping inside the room that was covered with asbestos insulation. And you can see it wasn't in great shape. So from this one room, asbestos was being distributed throughout all of the other offices. Here's what I was talking about in terms of these particles. And particles are not the only problem. As I said, if you're dealing with particles, that's only 1/7 of the issue. But interesting thing about particles that a lot of us don't realize is that most particles are smaller than 0.3 microns, which means even the very best filter, a HEPA filter, which traps particles above 0.3 microns, most of those particles actually go right through that HEPA filter. And so that's why it's so difficult to have a really clean, sterile environment, because you're almost always going to have some submicron particles floating around in the air. The thing with particles that a lot of us don't think about, though, is how those particles become little magic carpet rides for some of the bacteria, viruses, and other things that are floating around in the air. A bacteria doesn't have wings, but it does get on these submicron particles and float around in the air really for some period of time. That's one of the debates that people are having about viruses, is how long does it maintain itself in the air? Well, if you're talking about just the droplet of a sneeze, that may not last very long, but if those particles get onto a submicron particle that's already floating around in the air and maybe suspended in the air, how long would that stay actually in the air? So this is an example. I've been using this for years. If I'm standing at the podium at the rostrum and I'm teaching a class, I might sneeze and not hit the person on the very back of the class, that lady way back there in the back row. But some of those particles that were close to me when I sneezed are carrying that. And so if she sucks that down into her lungs and she's not had a real good night's sleep, she may get the very thing that I've got. And so that's why particles, it's so important to get particles removed. And there's a couple of ways to do that. A passive way of doing it would be sucking that to a filter and trying to trap it. Although you know as well as I do, when you look at a shaft of light, you can sometimes move your hands through that shaft of light, and those particles don't go anywhere because they're so light. What kind of jet engine would it take to be able to get that to a filter? But you can use proactive air purification technologies like multi-cluster ionization, and it can actually charge those particles and make them aggregate and drop out or get caught in a filter. So again, the solutions can be holistic, but they also have to be both filtration and purification to keep the air clean, and then by keeping the air cleaner, you're also going to keep surfaces cleaner. What about chemicals? We've got all kinds of chemicals going on in our environment. I've told people for years that we've got enough chemicals under our kitchen sink to kill a couple of elephants. The answer is to try to use greener technologies, and I'm talking about like enzyme cleaners, things that are less toxic than a lot of the chemistries that we currently use. One of the things that always amazed me about duct cleaning, for instance, is that a lot of people that have allergies get their ducts cleaned. And so the duct cleaner goes in, and he cleans the HVAC system, and he cleans the ducts and so forth, and then he sprays it with a chemical that causes the person with allergies to have a reaction. That doesn't sound very good. The point is, and it may be an unintended consequence of the way we do the work, but the point is we need to be conscious of the chemicals that we're using and make sure that they're not exacerbating someone's allergic reactions. One doctor said, which I think is pretty cool, we're sealing up our homes and offices with deadly precision. The idea is that after the Carter days in the early 80s, we started sealing up our homes and reducing fresh air makeup and making our environments almost like little toxic soups where we were just constantly turning over the pollutants instead of actually cleaning them. So this awareness of health concerns, it's got to be on our radar. And as an employer or as a facilities maintenance director, we've got to be aware that there are some current concerns that someone might have about our environment. So I'll tell you how this works. Barbara has lunch with Alice, and Barbara says, you know, I've been going back in that back area of the office over there, and I get a headache every time I'm over there. And Alice says, you know what? Every time I go, it's really funny you say that because I get kind of stopped up. And then they're talking about that. And then Ann shows up and Ann says, you know, every time I go over to that area, for some reason, I just feel really tired. Well, those are three completely different symptoms. But the truth is that they're sharing information that you need as an employer to say, whoa, maybe I need to deal with that particular environment, because oftentimes that's where health concerns come, or they're exacerbated by our environment. And that's going to affect productivity. Productivity can be affected by this allergic response. It's going to cost us dollars in terms of productivity. It's going to cost us time lost. One of the companies that we worked with, we were doing an assessment on their environment, and they were mostly concerned not so much about absenteeism, although that can be affected. They were mostly concerned about the person that just wasn't kind of 100% all there, not mentally, but from a health standpoint, because that company was so concerned about safety. They didn't want anybody to trip or slip or fall or drop a wrench. They were concerned about safety. And what if that person is just not 100%? How can we make a cleaner, safer, healthier environment where we can be sure that our employees are not losing productivity or having a bad attitude about this environment? Because bottom line is that just costs money. Sick building syndrome is defined as where 20% of the employees have some type of allergic reaction to that environment. And that's why it's called a syndrome. It may be a cluster of things and not necessarily all of them sneeze when they go to that area of the office. But as I said, one might have a headache, one might feel tired. It's just that 20% of the employees are reacting to this particular area or to the environment in general. Building-related illnesses, on the other hand, is where you can connect a specific illness with that particular environment. And so Legionella, for instance, is a really good example. Somebody gets Legionnaires, it came from that environment. And so if you could tie that through DNA testing to that specific environment, now you've got a legal issue that you've got to deal with. So it's really important as an HR person to track those illnesses, to track those allergies, people's reactions, be aware, be open, be honest, be listening, because the point is that we've got to make sure that we're aware of those issues before they become issues. And that's really just using your senses, the sight and smell and hearing and touch, not so much taste, but it's being aware of what's there and listening and talking so that you can be conscious of the problem. So this concept that Burroughs talks about in his book, he talks about 5 phases that any type of system should go through or assessment should go through before we actually get to a point where we're offering a solution. But he says the first 3, phase 1, 2, and 3, is something that a facilities maintenance director could do or an HR person could do. And that's the preliminary assessment, the qualitative walkthrough inspection, and the simple quantitative sampling or assessment techniques. That's something you could do in-house. You don't have to outsource it. Doesn't cost a lot of money. We do a lot of consulting for folks and talk with them about what type of DIY, do-it-yourself programs are out there. I'm going to show you one in a second. But what kind of equipment is there that you can take sampling yourself without having to go to the expense of using a very expensive lab? Walkthrough assessment, we've got an assessment process that we can help you with. And we also have a questionnaire that you might consider using to try to begin to find out if, in fact, there's an issue. So Barbara, Alice, and Ann might be given an assessment and say, what do you think about what's going on in this environment? Again, it's awareness. At this point, once you've done that, now you're going to look for a professional, phase 4 and phase 5, and that's going to be a more complex quantitative diagnostics. It's going to utilize some good equipment, some diagnostics equipment. I'm going to show you a couple of things here in a second. But it's also going to be included in that, if it's a solution-based assessment, which is what we do, and what we train on, it's going to take you to the goal of fixing what's there and then creating an environment where those problems are not going to come back. And so it's not about just finding the problem. I mean, anybody can find a problem. It's finding the problem, offering a solution, and then making sure that that problem doesn't come back. Our sanitization protocols always include these 3 aspects. First is green chemistries and cleaning, making sure that you're using the right kinds of technologies and that you're doing the cleaning properly and on the right schedule, which you all know about through ISSA training. Second is, the second component is air filtration and purification. We've got some great training, some of it free, IAQ Basics 101 training to help folks understand the 5 technologies that address air purification and air filtration. There are only 5 technologies that all air purification technologies are made from. It's either a filter, an ozonator, an ionizer, an ultraviolet light, or an ultraviolet light with target plate. So we talk about those and with the pros and cons of each and how you would look for the right kind of technology that could address both air filtration and air purification. And then the third component is scheduled maintenance. You got to keep up the program. If a filter needs to be replaced every 90 days, it needs to be replaced every 90 days. And so that scheduled maintenance program is incredibly important, making sure that the maintenance program, that the cleaning program, whatever that is done consistently. And that will obviously keep both the air and the surfaces cleaner. You might see this. This would be kind of a subjective view. You walk up in the attic. This is actually a house, but we see this all the time in Louisiana. This is a terrible way to do an HVAC system, the air conditioning system. Presents all kinds of problems, but I think anybody could look at that and go, spaghetti ductwork, not a good idea, not a good plan. This is something that would be very obvious to the trained professional. I looked at this. This was in a mobile home. And as you can see, the way it looks is the air should go in here, and then the air comes out of the top and goes into the duct system. They had a huge relative humidity issue and a gigantic particulate problem. Particles everywhere. It's as if the air conditioning system wasn't even working. Well, guess what? It wasn't. I looked at that and I knew that something was wrong. I took off the cover plates, and here's what was wrong. The air is supposed to go into the bottom right there and come out the top. Instead, they had the filter here, or the grate here, and it wasn't getting any air. So all we had to do was reverse this, put the grate on the bottom and the panel on the top, and guess what? It started doing what it's supposed to do, drying out the air. Sometimes it's really obvious when you've got water under an HVAC system, and we're always looking at relative humidity. Relative humidity should never be this high. Relative humidity should stay between 40 and 60%. That's according to ASHRAE, American Society of Heating, Refrigeration, and Air Conditioning Engineers. Should always stay between 40 and 60% because that reduces the possibility of mold growth, bacterial growth, and viral growth. So that relative humidity number is incredibly important, 40 to 60%. Particle counts. This is a professional particle counter that we use, although it's available to anyone, but it's going to tell you what the particle counts are. It's going to tell you the 5.0 micron and the 1.0 micron, so you can find out the large particles and the small particles, and you can make sure that your filtration system's working. I'll tell you how this is used in a very practical way. If you can have this in a air conditioning zone, you can tell very quickly that your filters are not working when the particle counts go up. So there are a lot of ways to use this, but a particle counter is a great way to identify whether you've got an issue with a high level of particles. Many of you are familiar with ATP luminometer testing and actually screening. It's not really testing, it's screening, as you'll see in just a moment. But ATP, utilizing a swab, can swab a surface. It's picking up adenosine triphosphate. That's what the ATP is. And that's something that's produced by every organism, microorganisms and human beings. And so on a surface, if it's contaminated, you can use a luminometer and it will actually read relative light units, but it will give you a microbial load on that surface. It won't identify what that is. It's not going to say it's mold or bacteria or viral, but it will tell you that it's a microbial load. And then when you clean off that surface, you can see if you've actually lowered the microbial load on that surface. But it's a screening technique. And there are a couple of problems with it, which is why we don't include it in our protocols. If you're using this, there's nothing wrong with using it, but recognize what it is telling you and what it's not telling you. It really is the concept of screening and not testing. So this study that was done by the National Center of Biotechnology Information, they did this adenosine triphosphate bioluminescence luminometer measurement in relative light units. And what they wanted to find out was how it affects disinfecting. Now, disinfecting, remember, is a next level of cleanliness above sanitizing, but I think it still applies when we're talking about our protocols for sanitizing. You'll notice in the summary it says, these results suggest that ATP meters cannot be relied upon to evaluate the effective disinfection of a healthcare surface, and in particular cannot be used as a tool to compare the effectiveness of disinfection between different disinfectants. These units have a number of limitations in detecting the true number of organisms on the surface, which can lead to false confidence in surface disinfection. So let me tell you why this is a problem even with sanitization. If you think about the size of a cell versus the size of a dead skin cell, the size is significantly different. This particular luminometer will not tell you what it's looking at. And so when it's measuring a adenosine triphosphate on a surface, you don't know whether you're looking at one cell, dead skin cell, or 10 million bacteria cells. All it's giving you is a relative light unit count of the contamination level. So again, not for protocols, certainly not for testing protocols, but it is a good screening tool to say, hey, maybe we got a problem, maybe we should go ahead and get a professional in here to take some more specific diagnostics. This is a do-it-yourself kit. It's an aerosol sampling kit. It's called My Mold Detective, and it's a really good, simple way of determining whether there's some issues with the air quality. But we also want to take surface sampling, and there are some DIY kits that will allow you to take swab samples. Those in some ways are really better because that's like reading the rings of a tree. That's all of the stuff that's been in that environment for a while and now has settled out. So even on a screening system where you're kind of doing it yourself, you want to do both air and surface, not just one or the other. It's really important. And of course, a professional doing a full-blown assessment is going to do both. Once we've got all this information, and let's say we've skipped now over to the professional assessor. Once he has all this information, he's going to be like Sherlock Holmes. He's going to use his building science background. He's going to use his tools for assessing the diagnostic tools that he needs. He's also going to use his own subjective evaluation of that environment. And he's going to then determine, like Sherlock Holmes, he's going to determine whether we're going to sanitize or remediate. So sanitizing exactly, remember, reducing the microbial load on a surface, that could be wiping it down. Remediation, on the other hand, is if you've got a really big mold problem, you have to tear out the construction material because it's contaminated and wet. That's a remediation process. In our world, from a consulting standpoint and indoor air quality mold assessment, 80% of the projects that we assess don't need to be remediated. They can be sanitized. Now, if you've got visible mold and you've got a certain amount of it, certain type of it, moisture content, so forth, there are criteria that we use for determining whether to remediate or sanitize. But in many cases, you can sanitize. And remember, that sanitization solution is the concept of green technologies, air filtration and purification, and a scheduled maintenance program. We utilize a data sampling interpretation chart to determine whether surfaces are contaminated or not, and we use this on pre and post testing. This is part of our professional practices, and this is just documentation from a lot of different sources to try to set some guidelines, some help, some standard for determining whether an environment is cleaner or not, and that's really the idea of that. This is based on thousands and thousands of samples. We created this microbial load reduction protocol, and this is a brand new protocol that we have put in place over the last several months. And it's not really the details. Obviously, the details are 3 pages of documentation, but I wanted to share this with you because this is part of a training that we're doing now called Certified Sanitizing Professional. And he can go in and he can lower the microbial load on the surfaces and in the air, which is what we're talking about, using best practices, how to sanitize the air and the surfaces. This protocol includes 7 steps. Step 1 you see is pre-screening, and so that's a testing process. Step 6 is post-screening, so that's the before and after, and to prove that the microbial load has been reduced. And then the 4 steps in between are the steps that you would be familiar with, lowering the microbial load by cleaning, and that's the cleaning techniques that you've learned by ISSA or would learn by ISSA of how to remove the dirt and the debris and the junk, because it doesn't do any good to go in and fog a really good antimicrobial or use a T360 to do a really good antimicrobial if it's just covering up dirt. So you need to remove the dirt. That's the cleaning process. Then you put down a really good antimicrobial, which is the preparation product. That's really cleaning the surfaces. And then the protectant is the next step, and that would be applied to create a surface on which mold won't grow. Some of those are nanotechnologies that are incredibly effective. Some of them change the pH so that mold and bacteria and virus won't grow on that surface. But that protectant step is a very important process. And again, we have training that supports all of this. Our certified biocide applicator training goes into a lot of detail about phenols and quats and silated quats. But that's not the place for this, but I'm just telling you that this protocol, again, is based on pre and post testing and then implementing the right kind of cleaning of not only the surfaces, but then the air. So you'll see step 5 is the implementation of air filtration and purification technologies. This particular protocol for our certified sanitizing professionals leads to our NORMI certificate of sanitization, which is issued to the client, and it just simply says that based on the protocols that were implemented and pre and post testing, that particular environment is considered normal or expected ranges. So contamination levels, remember, we're not talking about sterilizing, we're not talking about disinfecting at this point, we're talking about sanitizing the environment, and that's reducing the microbial load in that environment of the air and surfaces. So that's our NORMI certified sanitizing professional. If you want more information about that, that's at events.normi.org, something that you might be interested in. I want to thank you for your time today. I think we've covered a lot of material, but hopefully we've answered some of your questions. But I do want to emphasize at the end something that I think is incredibly important. We're not in the business of proving to someone that we've sterilized an environment. And if someone comes to us and they says, can you guarantee me that there's no mold in this environment? The answer is no. Can you guarantee me that there's not a virus in here? No. Can you guarantee me that this is safe? No. What we can guarantee is based on pre-screening and post-screening, we can sanitize the air and surfaces and prove that we've created a cleaner, safer, and healthier environment for you and for your employees. That's what we're trying to do. And I think that, that we've been successful in doing that. And I hope that we can be of some help to you as we kind of look at this new world and decide how we're going to sanitize our environments so that we feel better about being in a cleaner, safer, and healthier indoor environment. Thank you so much. And we look forward to talking with you again at another time when we can maybe do some more training in more detail. Thank you and have a great day.